Hi everyone. In this video, let's discuss problem C of Codeforces round 1000. Uh, Question named is remove exactly two. Let's first read the question, understand its requirement, and then we'll go through the solution. So you are given a tree of n vertices. You must perform the following operation exactly twice. So we are given a tree of n vertices first of all, and on tree we have to perform some operation twice. Operations is like we have to select a vertex B and remove all edges incident to B and also the vertex. So it is saying like we have a tree initially and we have to remove two vertices from it, like delete those two vertices and its adjacent edges. After removing those two vertices, please find the maximum number of connected component after performing the operation exactly twice. So after removing the vertices, we have to find the maximum number of connected components. So that's only the question is. So these are some definitions. So in the input, we are given n and n minus 1 edges. So basically denoting a tree, and we have to output the maximum number of connected components. So let's go through the TC. So first TC is there are two vertices with edge between them, 1 and 2. So it is like vertex 1, vertex 2 and the edge. So if you remove two vertex, like remove this and this, so the ending graph will have 0 connected components, so answer would be 0. For second, it is 1, 2, 2, 3, 2, 4. So second graph is something like 1, 2, 2, 3 and 2, 4. So here if you look like if we remove 1 and 4, then the graph we have is 2, 3, which is connected. So the CC will be 1. But if we select vertex 2 and 1 or 2 or 4 or 2 or 3, the ending graph would look something like this 4, 3. So total number of connected component here is 2. So for this tree, the maximum connected component we can get is 2 after removing two vertices. It can be 2 and either of rest like 1, 4 or 3. So this is what the question is asking for. So for solution, we need to first understand some properties of trees. So first of all, the given graph is a tree. So it will be all nodes will be connected as a single components. So suppose this is the tree we have in the sample. So all node here is connected through edges. Exactly if there are n nodes, then n minus 1 edges. Now, if we remove any of the vertex, suppose we remove this, so what would be the connected component of the vertex, like of the graph after removing this vertex? It would something look like this, 1, 2, and this connected to this. Here it will be 3. If we look closely, it would equal to the num in degree of the node that we remove. So if you removing this vertices, if it is a leaf node, then there is no change in the connected component because it will be connected to some node and we are removing this only. So there is no change in connected component. But if we remove some inner node, then the total number of connected component the graph will have equals to the in degree of that node. So this is one of the like main crux of this question. So basically we have to remove nodes which has higher in degree so that the connected component will be max. So first we have to remove one nodes which has the highest in degree, then we have to update others node in degrees, like this is 1 in degree, for this is 1, for this it's 3. So after removing this, we have to update the in degrees to zeros. Like for them, it will become zero because no, this node is removed. For this, it will become two. After removing this, we have to again find the nodes like in the graph which has the maximum in degree. Here it would be this graph because it has three. So for this sample, the answer would be to remove these vertices and these vertices to obtain the max connected component. So this was the intuition behind solving this question. So let's see the solution. You will understand more by looking at the code. So I have maintaining in degree uh, in the array and one vector for maintaining the adjacency matrix. I am reading n clearing. So for n minus 1 edges, I increase the in degree of a and b to 1 plus 1 and I add to the adjacency matrix. If there are two nodes, then removing those two nodes, the answer would be 0. Other than we will calculate the max in degree that we have currently. So we have to remove like the maximum whichever nodes which has a max in degree. So here we have I have used set to efficiently find the in degree of second node to be deleted because after we delete one node we have to like find the second node which has a higher degree or not. So for that I use set. So I am inserting in set in degree and I. So for I am iterating through n and whichever nodes has matches with my mx, I will erase that from set because I am deleting that node. I am maintain one temp answer, so my answer would be in degree minus 1 because second time also we are deleting. So if we delete these nodes, the connected component we can see is increasing to 3. But whatever we have, one of them would be deleted again to some in degree, like if it would be deleted to some 2. So basically we have to consider minus 1 here. So the answer would be incremented to in degree of I minus 1. Then I will erase the edges which like not the edges but yeah inset like I will remove those update basically I will update the in degrees of other nodes adjacent to the these nodes. So I remove I decrement the in degree and I add again. So my answer then would be the last element first. So last element in degree basically the last element having the max in degree. So I will increment it to temp answer and answer would be the max of all of those. I will whatever I did here like erasing part, I will reverse that. I will add again in degree of I and I and whatever I erase like by erase and minus and insert that I will do reverse like I will erase then add and increase the in degree and insert again the set. So this I am doing because there can be a nodes which there can be two nodes which has in degree matching with mx, so we have to consider all those cases. So this was the solution for this question. Hope you understood it. If there are some confusion, please ask in the comment. Thank you.